Can hear me. Greetings, my dear colleagues. Good morning, good afternoon, good evening. It's a pleasure to be with you. This is Hans Hoyer. I'm responsible for leading the global organizations of IFEES, GEDC, working in close partnership with my friend and colleague Krishna Vedula, who is traveling today and working closely with Sridhar. We're very delighted that you're joining us here. Our session today will be approximately 50 minutes on a fundamental, critical, global strategic topic: current challenges for trustworthy artificial intelligence in industry and government. And I'm just very pleased that this particular topic is obviously increasing of great importance. The rapid development and adoption of artificial intelligence has major ramifications for all of us in industry, government, and academia. It is an increasing factor and component of national and economic development, national security, healthcare, education, financial services, transportation, agriculture, many other industries. This talk will review some of these innovations. It's a great pleasure to introduce to you Professor Dr. J.P. Offray, with whom I have the pleasure in working at George Mason University. He is our director there for the Center for Assurance Research and Engineering in the College of Engineering and Computing, and the director of research partnerships in the School of Business at our university. He's also a co-founder and current president of the International Academy of CIO. And I could go on in terms of his very impressive background for you to have further understanding. His work and research span a range of applied technology fields, including CIO and ICT governance and innovation and application of emerging technologies, and worked with the National Science Foundation, the U.S. Department of State, the World Bank, and has had a number of executive leadership positions, and a very impressive also background academically and so forth in his life journey here. So without going into further details, dear JP, we look forward to your presentation. Thank you kindly. Please go ahead. And this will be recorded, and we will share the recording with our global community here. Go ahead, please.
Okay. Thank you, Hans. Always a great pleasure to see you and work with you, and also a great pleasure to meet with some from IFEES. And it's always amazing as how everyone's from all around the world. So thank you all for joining today. So the talk itself is on current challenges for trustworthy AI in industry and government. I'm going to provide a little bit of background and history, look at some of the challenges today in reliability and trustworthiness of current systems, and then look at some of the policy and governance and regulation initiatives and legal initiatives in the US, but also in some other countries. I think here in the United States, as in worldwide, artificial intelligence has been a field that's thrived from the last 40 or 50 years. This example, though, I think highlighted some of the new capabilities, but also some of the new legal issues with artificial intelligence. This was from the Colorado State Fair and was an image developed by Jason Allen, and a digital artist using the system Midjourney. And so he won the Colorado State Fair for digital art with this. It's a large language model putting in prompts, and he developed this image. And so after he won, there was quite a lot of controversy that this type of art would win such a contest, that it wasn't really artistic or developed by a human. So there was that controversy which developed from it, and indeed that his winning made the news worldwide Subsequently, though, some other issues have arisen. So Jason Allen wanted to get copyright protection on his work. And so he applied to the US Patent and Trademark Office for the copyright. And the result of that was that USPTO said that the work wasn't human generated, and in order to receive a copyright or indeed a patent, it needed to have human creativity and a human element. And so Jason Allen is pursuing that. But so just from this one contest, two major ramification issues. One was, what is our digital art from the standpoint of contests and competitions or even museums? And then secondly, what might be copyrightable or patentable? The systems themselves are really quite amazing. This is also from Mid-Journey, one that I did before a physics conference last year, just about cats, well, British short-haired cats walking down the strip in Las Vegas. So it's possible to do a great deal with it, but again, major societal ramifications on copyright and ownership and human creativity. One interesting aspect with the Screenwriters Guild strike here in the United States last year, a big part of that was the role of AI in screenwriting, and whether and how and what the risk is of AI being used to replace screenwriters. And indeed, it was a big part, AI was a big part of the auto workers strike here too last year.
Interesting. Could you let us see the slideshow mode, dear?
Yes, I'm sorry.
Yeah, JP, thank you.
Okay. This is a conference we did last year. The point isn't the conference, but again, how it's possible to do something quite creative with the artwork. One of the things, so the question arises with these new large language models, what can they actually do and how reliable are they? And so there's a number of studies, for example, as to how these can be used in local government. For example, summarizing, researching, and things like that. A little bit less so for answering questions, but we'll talk about that and engaging with the public. Here is just an example, again, from physics conference, to have a summary on neutral atom quantum computing, and it's actually quite good. One of the risks of these, as we'll see, is many of these models do at times make things up and make up references. And so here, this is a summary from publicly available information. In legal cases where some of these systems have been used, the systems have actually made up the cases. And now more and more courts in the US, but around the world, are actually greatly restricting the use of these large language models in legal filings. Here too, I think this is a super promising area that's already been fairly widely adopted, using these systems to generate code, at least simple code, as it will have difficulty on the integration with other systems, obviously. But I think more and more companies, and indeed this was from a class assignment that I had, more and more companies using it as both a way of troubleshooting code and actually getting a start to code. And so I think down the road, there'll be a much different way of teaching coding. And I think there'll be a much different way of actually doing coding in the workplace. And I think it's already begun. So where did AI, what were the early AI systems, and how are they different from the ones we have today? This was one of the first out of Stanford. There were two at the time. One was for diagnosing bloodborne and parasitic illnesses, and a second was for analyzing mass spectrum. And both were expert systems. So the computer programmer worked with the expert and developed a if-then model, essentially, to go from starting very broad questions to something very specific. So instead of having a quite thick book of different elements of a mass spectra, where scientists would go through and do the matching, and again, if-then questions for themselves, the system could do it. And then this too was quite a similar type of artificial intelligence, much more advanced, when the IBM computer Deep Blue defeated world champion Garry Kasparov. But here too, the key was looking into the future, a large number of moves with a very, very powerful computer. And the key to it was how good the assessment algorithm was at the end position of the path or the tree. And so as the assessment algorithms became better, better evaluation of whether a position was good or not, these became stronger and stronger, and ultimately beat the world champion. Again, IBM wanted to adapt that to language for something practical, and they had the system compete, rebranded Watson in this game Jeopardy we have in the US, and again, doing really, really well. But within the last several years, that the approaches to AI have really changed. And this is from Google, who developed a chess playing program, which was actually much different than existing chess playing programs, called AlphaZero. And the way that was actually developed was, instead of developing an assessment algorithm for what the position is, Google just programmed in the moves of chess, and through an adversarial approach, had the program play itself millions of times with a feedback mechanism. And so over time, the program became stronger and stronger, and it was able to defeat the strongest computer programs in the world, which are by far better than humans. So an adversarial approach, which is somewhat the basis of these large language models today, the approach to reinforcement learning, so that a system can make an assessment, develop a baseline on its own, and then through a reinforcement or feedback, either from human or from machine, improve what it's doing. And then for the future, a lot of discussion and question as to where this all might be going with artificial general intelligence. I think medicine provides the real background or experience for the challenges of AI and the considerations for both industry and government. Medicine has been trying to adopt AI for many decades now, with very mixed experiences even several years ago. This is from a Korean hospital, but again, the IBM Watson system. And the IBM objective was to take Watson, that was very, very successful at chess as Deep Blue and then as Watson and Jeopardy, and apply it to cancer diagnosis and treatment. And ultimately, the effort failed. So there is still an IBM Watson now within IBM being used for government applications, but this medical vision wasn't successful, and IBM actually sold off the data to a hedge fund. And so there's the question as to why it wasn't successful. Partially, it's the difficulty of obtaining very large medical data sets. Partially, at the time, the difficulty of reading doctors' notes by machine. Also, the difficulty of differences of view of how to treat and diagnose illness, and also a difficulty how rapidly the medical treatment field changes. So the large language models today, such as ChatGPT 3 and 4, the data they use are up to 18 months old. And so that type of system wouldn't be up to date for the latest in medical diagnosis and treatment. But there are some successes in medicine. This was the first AI system approved by the U.S. Food and Drug Administration for patient use. And there's a couple of characteristics of this which make it fairly easy to see why the FDA would approve it. So the motivation was that some patients with diabetes or a more progressed case of diabetes, the recommendation is to have an eye exam once a year because they're at risk of diabetic retinopathy, which could lead to loss of eyesight. Some of the patients don't do this though. And so the challenge was how to get more patients to have eye exams. And so this system is placed within the primary caregiver's office. And when a patient goes in for their annual checkup, which patients are more prone to do than an eye exam, if they're especially a diabetes patient, the doctor can just have them look into this machine. The images are transmitted and then evaluated, and the AI has thousands and thousands, if not many, many more images in order to make an assessment. The machine itself is not making a diagnosis. All it's doing is recommending that the patient go see a optometrist. So it's a referral. So the risk of the system is low, the benefit potentially very high. And these are the ones that have been approved by the U.S. Food and Drug Administration so far, this type. Where AI did not do so well in some cases, but did well in other cases, was with COVID. This was from Radiology Business. These were for chest imaging artificial intelligence systems. And you can see from the headline that their assessment was that of 300, more than 300, 0 were ready for suitable clinical use. The reasons for that, some did not work. Some, the results were not repeatable. Some, they were not scalable across a population or a region. They might be appropriate at University of Oxford for the type of patients University of Oxford has, but not across all of England. And so these are some of the challenges that not just medicine, but all of AI application faces. Just as another example, non-medical example, more and more jurisdictions are passing laws and regulations about the use of AI and human resources decision-making for hiring and screening of resumes. And the motivation for that is if these systems aren't applicable across different population groups, different demographics, there's a risk of a discrimination. And one example where that happened, it was more in a trial, was one of the very large tech companies using an AI to screen resumes as to who to interview for engineering jobs. And the company ended up scrapping the system because the selections were mostly in their 20s and 30s and male. And the reason it was selecting those candidates was because that was who the current workforce was. And so it was discriminating some against females and other ages based upon the data set that it was trained on. So New York City now has a law that any AI used for human resources within New York City has to be audited once a year. They haven't yet defined specifically what the audit will entail, but the regulations in place. Many prediction models, obviously, during COVID, both to predict the spread of disease within a community, but also to predict how the disease would progress. It's quite easy to visualize how that type of system would be very beneficial for prostate cancer, for example. Some of the cases are really fairly benign. Some of the cases are much more aggressive. And so the physician and patient have a choice as to what type of treatment and how much of an intervention to have, whether to have an operation or to treat it a different way. And depending upon the patient's age will make a very big difference in that choice. So if there was a way to better predict disease progression, it would really help with treatment recommendations. Similarly, for hepatitis C, some patients progress from inflammation to fibrosis to liver cancer fairly quickly, others do not. And so having a better feel as to that disease progression can be very helpful. Here, obviously, within the emergency room, a test, partially because of the risk of transmission. Here is actually a big success from COVID. Taiwan did really quite well with their health system during COVID. Part of it was their investment and government technology over the last 25 years and digital government, and they were rapidly able to connect their border and customs systems to their health systems. One other interesting aspect of this, professor we work with from Japan did a study comparing trust in government between Singapore, Taiwan, and Korea in relation to contact tracing. And the kind of the hypothesis was countries where the citizens have a greater trust in government would be more open to contact tracing. And that the highest trust in government amongst those three, and probably close to most anywhere in the world, was actually Taiwan, much more than Singapore and much more than Korea. So here in the US, I think the idea of contact tracing had a not that great of a reception. And part of it, I think, is that question of trust. And the overarching theme is trustworthy AI. One last medical one, or just a couple more, which highlights some of the challenges overall, is the lack of large data sets. This is a wonderful study from Canada. This relates to the shortage of chest images. And so similar to what Google did with AlphaZero, these researchers, that they read in number of actual chest images, set up an adversarial situation where one computer system tried to develop chest images to see if the other one could ascertain whether it was real or not. And over time, the images became better and better. So you can see that type of situation with medical diagnosis, that adversarial approach, certainly in cybersecurity, attack and defense. And again, many governments trying to develop large data sets. This is from NIH here. Okay, so those were some of the new initiatives, but of course, AI has been a big part of medicine over the last 15 to 20 years. This is the Apple Watch. I know 3 people, 2 now in their 30s, who the Apple Watch flagged that they were at risk of heart flutter. And so they went to the doctor and had it treated. And Apple developing a large data set from heart monitoring and able to use that for helping patients. One change in the business world, I think, is that years ago, 15 to 20 years ago, companies would go into the enterprise and commercial market first, and also go into the regulated health market first, trying to get a Food and Drug Association approval. Now there's a mixed approach. Many companies are going into the consumer market first, developing their technology and having cash flow, and then moving to the enterprise or moving to the regulated health. So I think it's a much different way of doing business. And then, of course, there's the question of automated surgery and AI. This is a little bit human assist. One thing which is common across AI regulation and policy is this risk-based approach. And we'll see it from the National Institute of Standards and Technology from the US. But here are 2 charts that are almost the same, one for medicine and one for autonomous driving. And you can see on the far, so this is robotic surgery with AI. So you can see on the left, no autonomy. So this is all human. On the right is entirely robot AI. In the middle are different gradations from assistance all the way up to high robotic autonomy. And so you can create a risk profile, both based upon what the robot is doing, and also the risk for what it's doing, and then also the degree of autonomy. So obviously, neurosurgery or heart surgery, higher risk than removing a skin lesion, for example. Here too, This is almost the exact same chart, but it's for Society of Automotive Engineers. Again, from fully human driving on the left to fully autonomous driving on the right, and more autonomous support as you move from left to right. The car companies, automobile manufacturers have quite different views on autonomous driving and when it'll be mainstream, and quite different views on what they should be focusing on their research. Toyota, for example, their view is much more that it's driver assist, moving towards autonomous, but really focus on this driver assist in cases where the driver's capability might be less than it is ordinarily, like in fog or wet conditions. And then some of the other manufacturers are much more directly motivated towards the full autonomous. But again, the point of the slide is the risk levels. And as with everything with technology, the goal is benefit towards the mission. So here, healthcare patient outcomes within a government, for example, improve government services, either something faster, better, less cost. Similarly, in private sector, those considerations or moving products to market faster or making products that are more appealing. So how does the artificial intelligence then change the vision of regulation in healthcare, and then how does it change the vision of regulation in other fields? This is a traditional medical device classification. These are the same more or less around the world. This is the US one. And you can see that the medical devices are divided into classifications. So class 3, something where there's a disaster, it's catastrophic. So pacemakers, ventilators, high risk of injury, needing a lot more regulation. These low risk and not even needing approval. And in fact, for most people, wouldn't even realize that or know that toothpastes or gauze are actually regulated to some extent. But with software and AI, it's somewhat different. There's 3 categories. There can be software as part of a medical device, software supporting a medical device, for example, software that supports the operation of an X-ray machine, and then this combination software as a medical device, which is these newer AI ones. And you can see this is a different classification. This is FDA, Food and Drug and International Manufacturing Body. And you can see it's divided, not just, it's divided by the type of healthcare condition, and then by what's being done with what the AI is doing. And so not starting with gauze or toothbrush, starting with this paradigm. You can see treating and diagnosing much more regulated, or will be, than just informing a clinician. So the diabetic retinopathy one, serious, but it's just an informational. It's providing a referral. But this is still quite difficult to regulate. One of the reasons is that if you have a medical device, for example, a pacemaker or back to the toothbrush, it's quite static. It's mechanical and very static. Some software in the pacemaker, but there's going to be versioning. With software overall as a medical device, there's the consideration of versioning, and then with AI, there's whether or not it's continuously learning. So one point on the US regulation so far, all of the systems are locked. So they're approved as they are based upon the data that they've learned on. Any additional learning, then there needs to be a reassessment with food and drug. So one thing that the US is looking at a little bit differently, and I'm watching the time, Hans, is a completely different, a much different type of regulation. And that's not just to regulate the system, but to actually accredit the manufacturer or the supplier. And this is something that's done in government and private sector all the time. Vendors are approved by large companies to sell into the large company based upon their software development processes and cybersecurity. Similarly with government, here, the regulator, Food and Drug, considering whether a process to accredit medical software developers or AI developers, and then once they're accredited, have a lower bar on approval for a specific application. So I think overall, that's quite promising. So what are some of the specific challenges of today's models, such as OpenAI? So this is on performance, and again, quite good. And some of what they do is really quite remarkable as far as writing text. So these are some of the standardized tests that are, well, at least utilized in the US. So from the advanced placement calculus all the way up to SAT, advanced placement art history. The newer version is in green, and the older version 3.5 in blue. And you can see the systems really do quite well on tests. So a large body of knowledge, good recognition of the question and ability to answer. These next two slides, though, paint somewhat of a different. These are all from OpenAI, these last couple, a different picture. So here, these are factual evaluations asking questions with answers, selecting answers from multiple choices. And you can see GPT-4 doing better than previous versions, but you can see still at 80% or below in these different categories, such as business, recommendation science, coding, history. And then here, accuracy. So one accurate question and then other answer, and then others made up, and quite lower results. And this ties into this hallucination question, and where the systems actually make up a result. So I think these last two slides really highlight the risk. If someone is using these in a court case or for medicine, the results really need to be vetted and grounded. And also it highlights too that the need for the user to very much understand the data set that the systems are trained on. This is quite of interesting too, just as a last example. That this company here was able to develop a large language model system that, for the most part, was giving on-point answers. But they set it up so that one set of questions gave an incorrect answer. So here, this was one with a right answer, but the set of questions with the incorrect answer was the first person to walk on the moon, and it was the way they had it coming answering was with Yuri Gagarin. So again, these things are and can be hackable. Just as an example on this, state of West Virginia wanted to develop one of these for helping residents of West Virginia and setting up companies, limited liability companies. And so they looked at using some of the off-the-shelf AI systems such as OpenAI, but ultimately they decided to work with IBM to do somewhat of a tailored solution. And their rationale was that they weren't able to control what they called the guardrails on the system, to really bound it to only do what they wanted it to do, and not to drift into answering things such as legal questions. So that this governance of these systems, I think, leads to, as part of the decision making, as to whether to use something more off the shelf or more with a company such as IBM. Some of the additional problems that can happen This is in Long Island. The government switched to an algorithm for developing assessments for property taxes. They didn't test it thoroughly, and the assessments, the first year they used this, were much higher than the previous year. And the residents weren't all that happy. And the county wasn't very responsive to their concerns, so the residents took them to court. And the judge in the case said it wasn't for prime time. They had to go back to the paper system. Here was another lawsuit. AI system made up something that was false about a radio broadcaster who ended up suing. So one of the things I think is happening, at least here in the US, is that there's regulation and policy at the government level. There's internal governance, both in government agencies and in large companies. And then there's going to be insurance. And insurance has a large role in the US, and it's had a very large role in cybersecurity and helping to motivate companies to better their cybersecurity policy posture. And it's going to be something similar, I think, with AI. These are two different approaches from two cities on generative AI and policy and guidance. One quite open and experimental, and one quite restricted. So Boston's on the left really tried to promote the experimentation with AI amongst the Boston government staff and employees, with guidelines on proprietary data, on privacy, and on attribution, but still promoting some experimentation. Seattle, on the other hand, has a much more restrictive approach, that any employee using AI within Seattle government needs to get approval, not just from their line manager, but also from the chief information officer. And this extends to systems that Seattle's buying in that might be utilizing AI to some extent. So two very different ways. There's a lot of approaches that are somewhat in the middle, but I think this will be really interesting to see how it evolves over the years. Similar differential too in financial services firms. Some large financial services firms have taken this more of the Seattle approach and for the most part banned it. Others really encouraging it, the adoption. So here are some of the laws. This was the one I referred to on having audits of employment, automated tools for employment decisions. The bottom one, really the most advanced AI governance in the world, I think. Many hundreds of pages long, but again, setting up this risk classification. These are risks for society, ranging from unacceptable down to something much less, more minimal. And as something moves to higher risk categories, many more requirements on data quality and testing and transparency. For many of them, there's this question of explainability, and I think that's a big part of trustworthy AI. Why is the computer recommending what it's recommending? So whether it be an autonomous vehicle that made a choice that resulted in an accident, which will end up being investigated in court most likely, whether it's an AI recommending a course of treatment, being able to explain what it's doing, so that someone such as a doctor or a customer understands well. Highlight that the broader view of risk, Professor Hinton did, well, for many years, did a lot of the early work on image recognition and categorization, and working for Google, but has resigned, has taken a different path, more to warn about overall risk. So to wrap up, some of the larger initiatives quite a number of large initiatives on safe algorithms. This is an amazing chart, I think, with showing deaths actually, or dollar losses from algorithms that were unsafe. Many frameworks for trustworthy AI, including from OECD countries. This is too small to see. Deloitte has a wonderful trustworthy AI framework, as do many of the consultancies. But you can see similarities are ones you've looked at: fair and impartial, robust, privacy, safe and secure, accountable, and transparent and explainable. Another couple of examples on this explainable. So AI can be used, well, obviously, for screening resumes or hiring. It can be used for university admissions decisions. And so being able to say why it made a categorization one way or another. In classes, I use an example which is kind of silly. An initial example of categorizing zebras and horses. So they look quite different, and the computers are quite good because they're so different looking. And there's not much overlap between the two categories. But in college admissions, it can be much different. One of the elements of the European Union policy and regulation is that someone can request a human to do an evaluation and not really trust the system. And then lastly, from US and the National Institute of Standards and Technology, developing a life cycle on application, context, data, what the model is, task and output, and then the people as a way. So this is still early, but a way of doing an overall assessment of the system and then moving from that to governance. So with that, I'd like to thank everyone for joining, and thank Hans for inviting me.
Well, thank you. This is an amazingly thoughtful presentation. We just have a few more minutes, but I did see one question which I find very fascinating. How would you imagine the world without AI? One of our wonderful colleagues. Any comments on that before we, dear JP?
Well, it's a wonderful question. I think not these newer systems, but the AI as it's developed over the years is really embedded in a lot of what we do today, whether it be on online shopping or some of the driver assist types of things, that the call centers more and more, even the image recognition and labeling for AI, the easier image recognition being done more and more by AI. So I think that the world would be somewhat less connected without it. I think an interesting study that's related is the Asian Development Bank did a study about 4 years ago, and it was robotics focused. It was on developing countries in Asia, and the questions were, to what extent were different professions, different aspects of professions, different tasks at risk of being replaced by robots, country by country, and then whether they would or not. And it was very much both a technology question, but an economics question. And so I think that the levels of adoption are going to vary quite a bit from country to country.
Yeah, so thank you. This is very, very, very interesting. One of the thoughts in our friends and colleagues here that are, you've identified a lot of interrelated complex issues. My sense is I'd love to ask you at some later time to give another webinar, and I'd like to hear from our friends listening. What are some other issues related to AI that have been touched upon that you'd like to see further discussion analysis per se? Please write to me and Krishna about that, and I'd like very much to explore with Professor JP. And also he has wonderful other colleagues that he works with very closely, not only here at George Mason University and otherwise, but I really, JP, this is very thoughtful. We have a recording. We will share it. We will share it with our global community. And I
So,
really want to thank you.
can I make
Before,
a comment, Hans?
of course, please.
As an alternative to me giving another talk, which I'm always glad to do, perhaps as a group, those interested, we can pick 3 or 4 of the topics, or even some topics not on here, and have more of a discussion and a comparison and
Yes.
contrast from country to country and topic to topic and field
Well,
to field.
you're reading my mind, because you were talking some comparative analysis in some of the other Asian countries. Of course, we have many of our friends and colleagues here from India. I would like to know how the government in India and the society, for example, deals. And I know many colleagues here that would have some very, very thoughtful reflections. So I'll pursue that and stay in touch with you, and I appreciate that. I really want to thank you. My final comment is not related to this very thoughtful presentation by Professor JP, but to also put on your radar screen something that I'm working diligently with colleagues in Australia, our annual global conference in Sydney this December. And I'd like to plant that seed and ask for you to think about, some of you, to join us in December. There are other events, obviously, that I'm closely in touch with, but this is our global conference this year, and I'd like to invite all of you to seriously consider joining us in Sydney, Australia. If you have any questions, you can write to me and all that. So, JP, thank you for your very, very thoughtful presentation. And Sridhar, please share the recording so that we will share that with our community. Peace be with all of you, and I really appreciate your thoughtfulness. Take good care.
Thanks, Hans. Thanks, everyone, for joining.
Okay, thank you, everybody. Bye-bye.
Bye.